fundamental theorem of algebra, Carl Friedrich Gauss said, if it has an x in it, it has an answer. And mathematicians all over the world freaked and said, let's find them all. And so part of what we're doing is continuing on in our search of how do I solve absolutely everything? And now by the time you leave Algebra 2, you won't know how to solve everything, but you will have a big chunk of it learned. So our objective is to solve square root and other radical equations. And I like this first one because even though our book's getting kind of old, it was published in 2011, so it's 10 years old now, this is something that is still somebody's job right now. And in fact, it's really important for cell phone companies. So you're a passenger in the car. You're using a cell phone that connects with the cell phone tower shown. So there it is. The tower has an effective range of 6 miles. How many miles do you have to finish your call and justify your answer? So this says we're at 3 miles right now. But what's really happening is there's this gigantic circle of 6 miles around that cell phone tower. And when you drive outside of that cell phone tower, your call gets dropped. Have you all had that happen to you before? You're calling and you're talking to somebody and you're in the vehicle and all of a sudden, well, that's the end of the call. It's just done. That doesn't happen a lot in Minnesota, mostly southwestern Minnesota. Yeah, on the map, this stuff up here. Because there's lots of swamps and that type of thing, and so they don't have cell phone towers everywhere. But this is somebody's job to figure out where are these drop zones, because they don't want customers to call in and say, we're through with you because I drive this route every day with, of course, my hands-free phone, and I make my phone calls and I always get dropped. That can't happen. I have to have a service provider that's going to provide the cell phone all the time. Well, eventually, the person that does this, that takes those calls and figures out how far we're talking of for cell phone range, is going to figure out we've got too many complaints and we need to do something about the cell phone tower because it's not reaching everybody's calls. There's a spot that's not being met. And so what they'll do is they'll contact people that have like a really big barn, or they'll contact a church, and they'll say, for a small fee every month, would you be willing to put a cell phone booster on your building? And it just looks like, a metal pipe going up and a piece of metal, basically. And sometimes they can even hide it, especially in where they have the bells in the church, they can hide them up there and pay the church a little bit of money, and they won't have that bald spot anymore when they're doing this. So we're not going to actually figure this one out, but this is important because, like I said, it's somebody's job. And circles have this as their basic equation, x squared plus y squared equals r squared. And it's somebody's job to figure that out. So if they have to figure it out, this is lots of squareds. And we know that you undo squaring something by taking a square root. Well, that means we have to be able to solve stuff that requires square root equations. And that's the basis for not only cell phones, trucking would also be interested in this. They want to be able to get a hold of the people that work for them at all times. There's just so much now that relates on communication, and being able to get in touch with other people. So, radical equation. Pretty self-explanatory. It's an equation that has a variable in the radicand or a variable with a rational exponent. So if we see a radical and we see an x under it, we're talking about a radical equation. And what we're going to do today is make sure that we can solve those. Now, we don't just use radical equations. We talked about this last week, that in the process of working with radicals, we found out there's some stuff we had to say, we can't do that with radicals. So we changed them into fraction powers. And either way, when we're working with those, because like it says, it could be a rational exponent, we might end up looking at square roots, cubed roots, fourth roots, all of those types of things. So a radical equation is the equation that has a variable in the radicand and or a variable with a rational exponent, making this a fraction power. And a square root equation is an equation with a radical index of 2. Kind of a duh moment. I mean, we know that. We've talked about square root having a little 2 for an index. In this lesson, all radicals and expressions with rational exponents represent real numbers. We're not going to have any imaginary stuff show up in our solving. So here's the big one. Essential understanding. We must know this. Solving a square root equation may require that you square each side of the equation. Well, yeah, I mean, they just got done talking about square root equations. If you want to undo square root, you have to square it. That's how it works. Well, guess what? When you do that, when you raise both sides of an equation to an even power, sometimes you can do all the math right and you say, this is the answer I have. You plug it back in and it doesn't work. It's a real letdown. That's called an extraneous solution. And yeah, a lot of the times it happens because we have to raise both sides of an equation to an even power. That means we're going to have to check our answers. We have to know that they're going to work. All right. Well, we know where we're going. Our objective told us we have to be able to solve these things. So, to solve a radical equation, isolate the radical on one side of the equation. Okay? To isolate means get by itself. So they're saying whatever the radical has to be just the radical on one side. It's going to look like this. Some radical equals something. But what we can't have over here on the left is plus 5. Can't do that. Times 7. Nope. Can't do that. If those things are there, we have to move them over to the other side. Isolate the radical. Get it all by itself. And like it says, after that, we'll raise each side to the power suggested by the index. I know that sounds complicated, but it's not. If it's a square root, square both sides. If it's a cube root, cube both sides. It's stuff that would normally be instinct for us. So isolate it, solve it. That's what we do. Problem 1, solving a square root equation. And in case that's kind of hard to see, let me write it a little bigger. Although that photo looks pretty clear. Some of them are a little bad. Well, step 1, they said, was isolate the radical. Is it isolated? No. There's something over there with the radical. So we have to figure out how do we get rid of that 3 plus. How do we get rid of it? Subtract 3 from both sides. Did it. Been there. Got the t-shirt. All right, then they said if you isolate the radical, so it's just radical equals something, then you should think about what the index is and how you can use an inverse to get rid of it. Well, that's a square root. How do we undo square root? Square. And what we do to one side, we have to do to the other. Well, that was a piece of cake. And we totally know how to do this. We're just 2 steps away from solving it. We'd add 3 to both sides. And divide by 2. Yes! Score! Goal! Oh, wait a second. They said sometimes even though we do all the math right, because we raised it to an even power, that answer might not work. Huh. All right, well, we better check it then. So, if we take this and put it right there, 3 plus the square root of 2 times 14 minus 3 has to come out to 8. So this is just checking it. Square roots, any radicals, work like grouping symbols. You have to do all the stuff underneath them first, as if they were parentheses, and then you can continue on. So what's 2 times 14? 28. Minus 3?
25.
So 3 plus the square root of 25 is supposed to equal 8. What's the square root of 25?
5.
It is 5. Well, look at that. It's going to work. Big check mark. Yay, us. It was golden. We got it. Now, after we do a few of these, people will sometimes say, Cedarholm, you have us check all of them, and they always all worked. Why would I continue to check these? Because, there's probably going to be at least one on the test that doesn't work, It's like when you do the homework. 18 of them in a row, all work. On the 19th one, you say, I'm not checking this. These have all worked. And it's the one where they don't. So, we have to make sure we check them all. What is the solution of this little Hummer? Help me out. What's step 1? Yes, have to isolate the radical, so we have to move the 5 over. Step 2. Thank you. And so I look out and I see everybody like this. Now that's a good thing. That tells me you feel like you know what you're doing. So you keep going, I'll keep going. Let's see if we get the same thing. I got a 6. Did you get a 6? Well, that doesn't mean we're right. You have to check it. I mean, it's a good sign, but you need to check it. Alrighty, what's 4 times 6? 24, add 1. And square root of 25? Oh, it's looking good. Boom. 6 works. If you wanted to, you could check with your graphing calculator too. It's just with this one, I think especially with the radical in there, it's probably easier to just check it with your noggin and go through and say, hey, this is how I find this. Now we're getting to those where you might want to be checking with your graphing calculator, and that's going to be the fraction powers, because I know some of you don't necessarily appreciate those fraction powers that we have up there. This says to solve equations of the form x to the m over n equals k. Here's what you need to do. You need to raise both sides of the equation to the n over m power. Wow, does that ever look like a mess, huh? Well, how does that work? Anybody see it? How does this just become x? You have to multiply because you're raising a power to a power. And these n's will cancel out, and these m's will cancel out, and you'll get an x to the first. So that's why we raise it to the reciprocal power, is to get it to be x to the first. So raise each side of the equation to the n over m, which is the reciprocal of m over n. Now here's the kicker. If either m or n is even, so when you do this, raise it to a number, something in here is even, then we have to think of it as absolute value. Now, I'm going to tell you this book is overcautious. And that's because it's not entirely true that if either one of these is even, that you have to think of it as a plus or minus problem. The truth is, you have to think of it as a plus or minus absolute value problem when the denominator is even. Now let's see why. I don't know why I picked up the blue. The blue is always an issue. Oh, sorry. I didn't mean to talk badly about you either, Bluey. It's okay. You're doing your best. I know it. All right. Which of those is the index? When it's x to the 3/4, which is the root? Yeah, the bottom one. So here's the deal. When we take square root, 4th root, 6th root, 8th root, those answers are always plus or minus something. And that's why they're saying we need to put a little extra thought into this. When you raise it to a number that has an even number in the denominator, you have to remember plus and minus were both an option. So maybe we better see one of these and see what it is they're talking about. 3 times the quantity x plus 1 to the 2/3 equals 12. All right. Step 1. Excellent. Yeah, you have to have the radical all by itself. And I know you're looking at this saying, that's not a radical, Cedarholm. Remember, yes, it is. It's cubed root. So we have to divide by 3. We have to isolate the radical. Now it's isolated. Now what? I see we're all using the stare at it and hope it goes away method of mathematics. Is it working for you? Because I can still see it. Is it working for me? We should raise it to what? Well, flip back if you need to. Raise it to the... Thank you! Well, on the left-hand side, that's fabulous, because this is going to be x plus 1. On the right-hand side, we need to be careful. Which of those is the root? The 3 or the 2? The 2. When you take the square root, is there only one answer, or are you supposed to do plus or minus? Plus or minus. Because what we just did is we said it's the square root of 4 cubed. Oh, that's plus or minus 2. So this is actually going to break into 2 equations because there's 2 answers that we could have. It could be negative 2 times negative 2 times negative 2, which is negative 8. But it also could be 2 times 2 times 2, which is 8. Oh, Cedarholm, the book said put an absolute value in there. Yeah, I taught it that way for probably the first 6 years, and people didn't get it. The absolute value made it way too complicated. So if you need the absolute value piece, you'd stop right here and put it in there. And then you'd have to think of it as plus or minus 2 as you go through it. So over the years, more people retain it, remember it, when I do the split like this. You do what you have to do. All right, we're not quite done, but these are little one-steppers, so go ahead and get them. Maybe they both work. Maybe only one of them works. Maybe neither one of them works, and we have to put no real solution. We're not going to know until we check. So let's check. 3 times negative 9 plus 1 to the 2/3, does that equal 12? 3 times 7 plus 1 to the 2/3, does that equal 12? And this is where I said more people tend to use their graphing calculator to check these than people do the other ones that we did with the radicals. So usually people will say, well, I'm going to do this in my noggin because I know negative 9 plus 1 is negative 8. And I know 7 plus 1 is 8. But see, Jerome, I don't want to think about the rest of it. So I just really like to punch that in. And now this is where my calculator started to go weird last hour. So it's all good, calculator. I'm not going to make you work too hard. It's okay. 3 parentheses negative 8 parentheses to the parentheses 2/3 or 3/2? 2/3, okay. It's 12. Now, all I want to do is take the negative out in front of the 8 because I want to check the other one. So, what you can do is you can hit second enter and it pulls up the last thing you just punched in. And then I can go back here and just delete that negative by hitting the delete button right there. Not that this would have been, really bad to punch in again, but another thing your calculator does. So they're both 12, which means they both work. So Cedar Home, how do I show that if I use the calculator to check on my test? You're going to write GC check, and that'll tell me graphing calculator checked. But make sure you do it, because sometimes people put GC check on everything, but then one of them doesn't work, and then I almost want to take off more points for lying. So if you're going to put GC check, make sure you actually checked with your graphing calculator. Alrighty, here's B. Wowzers, look at that one, huh? All right. Well, first things first, we have to isolate that big mess. So what should we do to get it by itself? Oh my, got carried away with my square root. No, that was my line. There. Yeah. We have to isolate it. Now, some people would say, okay, I'll take the 5th root and then I will take the cubed root, or raise it to the 5th power and then I'll take the cubed root. Well, why not just make it a fraction exponent at this point? It's almost there. We know the 5 is supposed to be the denominator. I'd rather do that. Put 2 steps into one. Now, if you did that, if you're like Cedar Home, I raised it to the 5th power on both sides, then I took the cubed root, and everything's cool. As long as you do it right, perfectly fine. So what power should we raise both sides of this little monster to? Thank you. You're doing it already. I can see that from up there. Everybody's writing like crazy. So right now we have x plus 1 equals 8 to the 5/3. Which of those is the root? The 3. What's the cubed root of 8? 2. Any chance it could be negative 2? Not cubed root. Cubed root only has one answer. 2 to the 5th. 2 times 2 times 2 is 8, times 2 is 16, times 2 more, 32. And we subtract 1. And maybe, just maybe, the answer is 31. Gotta check. Okay, 31 plus 1 is 32. So everybody tell me 32 to the third power. You've all got that memorized, right? Nobody memorizes 32 to the third power. Let's see what that is. Please behave, calculator. Thank you. 32,768. Don't suppose that shows up on our power chart, do you? Fifth root, 32,678. Fifth root, well, look at that. It's 8. It's on there. What's 3 times 8? 24 plus 1? 25. 25 equals 25. It's a winner, winner, chicken dinner. There it is. It worked. So, again, we need to check them. The one we don't check will be the one where it doesn't work. All right. This is the one that's really hard to see. I think that says 2/3. Is it 2/3 in your packet? Yeah, it's just so hard to read here. Hope it showed up a lot better in your packet. All right, what are you doing? Because I know you already started this one. Uh-huh. Then raising it to that reciprocal power. But now we have to be careful. Check out the denominator of what we just raised that to. Square root. So let's think for a second. Square root of 4. And. Yes. Remember, whenever you physically write an even root, I got to write it backwards. Physically write an even root, you have to do plus or minus. So this is going to be plus or minus 8. Let's break it up into our two equations, see what we get. I'm going to tell you this right now. This is the difference between somebody getting an A and somebody getting an A minus on the test. Happens every year. Somebody only solves the positive of this. They forget about the negative. So if I were you, I would put a big star right there. So right before the test, you can come back and take another look at these and say, I am not going to be the person that forgets the negative. Two answers. Let's check them. Negative 11 and 5. So 2 times negative 11 plus 3 to the 2/3 equals 8. 2 times 5 plus 3 to the 2/3 equals 8. Again, with the fraction powers, people really like to check these on their graphing calculator. And when I taught at third hour, I'm like, deja vu, didn't we already punch this in? But there was one difference, wasn't there? It was a 3 in front of it last time, not a 2. So we need 2 parentheses negative 8 parentheses to the parentheses 2 divided by 3. It's 8. Second enter. Go back and delete my negative. And it's 8. G, C, check. Checked it with the graphing calculator. You, of course, could have done this in your head, too, if you wanted to. You know, you could take the cubed root of negative 8, square it, multiply it times 2. You You can do it in your noggin, but most people like to use that graphing calculator for these with the fraction exponents. Word problem. Woo! That looks like a monster. For meteor crater in Arizona. It's a real thing, by the way, and I always think how unoriginal that name is. But it says exactly what happened, so it's a meteor. It created a big hole. For meteor crater in Arizona, the formula d equals 2 cubed roots of v over 0.3 relates the diameter d of the rim in meters to the volume v cubic meters. What is the volume of meteor crater? Well, we don't deal with kilometers a whole lot, so right now we'd be thinking, well, you'd have to explain to me what a kilometer is, so I'd know whether or not this is big or not. Well, it's not supposed to be in kilometers. Right here, it says it's supposed to be in meters. So they were trying to pull a fast one on us. They were trying to get us to put 1.2 in there for D. But that's 1.2 kilometers. And we all know there are 1,000 meters in a kilometer, so we have to move the decimal over 3 places and put that in meters. Now we can put it in for D, because that is the diameter of that big meteor crater. Now, we've solved tougher stuff than this today, so what are you doing for your first step? Because I know you're already doing it. How do you undo cube root? Cube. Both sides. And notice I'm not going to punch that in just yet. I want to punch it all in at once, so I don't have to leave my screen 800 times. So how would I get V all by itself? Yeah, because this is division. That's what's going on here. So we need to multiply both of these by 0.3. 0.3 times 600 cubed. And this is where my graphing calculator freaked out on me. No freaking out, graphing calculator. That's better. That's a lot of zeros. Because that's a big crater. 64,800,000 cubic meters. It's a big one. I have never seen it. I've been out there once. We went to Hoover Dam once. Never saw it. It's got to be pretty big. Now, this says, suppose the diameter of a similarly shaped crater is only 1 kilometer. So what should we put in for 1 kilometer? We're not going to let them mess us up with the labels. So 1,000 equals 2 times the cubed root of V over 0.3. You know what? You do yours, I'll do mine. Let's see if we end up at the same place, because most of you have your heads down and you are just going to town on this little bugger, which is fantastic. That's what I got. Is that what you got too? I didn't punch it in wrong or anything like that? Good. Good. So even if there's a formula and you're like, oh, word problem, well, don't spaz out because it's a word problem. You just be extra careful and make sure the labels are what we expect them to be and what we're supposed to put in. But that's as far as we're going today. Now, why aren't we done? What could we possibly have left? We did it. We solved radicals and we solved fraction powers. That's what we were supposed to do today. We've solved some of the easier roots and fraction power problems. So tomorrow we got to take it up a notch. Right now, you need some practice on these. So 9 through 25 the odds, so you can check all your answers in the back of the book. And then 77 to 84, please.